Hey YouTube, welcome to my last episode of integration. Today we're going to look at further area problems, so applying all of the skills we've learned so far to specific area problems. Guys, check out my new mic. Do you like it? Does it sound better than the last one? Let me know. My students have been loving it. They think I'm some kind of like gamer streamer, but yeah, if it sounds better, just let me know. And also, any of you A-level students, check out my last video where I did a walkthrough through one of my predicted papers. So that's for students in year 13. But getting to this area problems question, we have an area that we want to find. We have the figure shows part of the sketch, shows a sketch of part of the curve C with the equation y equals x cubed minus ax squared plus kx, where k is a constant. The point P on C is the max turning point. Now, maximum turning point, immediately I'm thinking about gradients. Given that the x coordinate of P is 2, show that k is 20. All right, maximum turning points, gradients, and especially gradients equaling 0 for turning points. So we need to differentiate this, bring down the power, knock one off the power, minus 16x. Then kx just differentiates to k. Remember, k is just a number. So like 2x differentiates to 2, kx differentiates to k. Now this gradient has to equal 0 when x is 2. It says the x coordinate is 2. When we sub in 2 here, 2 squared 4 times 3, 12. 2 lots of 16 is 32. This should equal 0. We get minus 20 plus k is 0. So k is 20. Part B. The line through P parallel to the x-axis, that's the y-axis at Q. The region R is bounded by the curve C, the y-axis, and PQ as shown shaded. Calculate the exact area of R. All right. There's two ways you can do this. Either we can say this is an area between two curves, between 0 and the x-coordinate of P, which is 2. Yeah, that's utilizing what we did in the last episode. The most common way to do this is to find the area of this rectangle, and then we subtract this area underneath the curve between 0 and 2. So you can see when I shade that in, we form a rectangle. I think that's the best way to do this. Now, how do we work out this rectangle's area? Where we have a base length of 2, we need the height. Now, where are we going to get the height from? Well, we just take 2 and sub into our equation of the curve. So we're going to get y is 2 cubed minus 8 times 2 squared. K is 20 times 2, 16. The height of this is 16. So our rectangle area is just 2 times 16, 32. Now we're going to find the yellow area. That is the integral of our curve between 0 and 2 of x cubed minus 8x squared, and k is 20x dx. Add 1 to the power 4, divide by 4, would make it a quarter. Then we'd get x to the power of 3, then minus 8 divided by 3. Then here we have 20 divided by 2, so 10x squared between 0 and 2. So now we need to sub in 2, and then we'll subtract subbing in 0. Now subbing in 0, guys, it's all in terms of x, so subbing in 0 is just going to give you 0. So you only need to sub in 2. Subbing in 2 gives you 68 over 3, minus subbing in 0 gives you 0. Our final answer, guys, is 68 over 3, and you can say units squared if you want. Now finally, to work out R, remember we're doing the rectangle minus the shaded area. So we're going to do the rectangle's area, which is 32, subtract 68 over 3, and then doing that on our calculator just to avoid any silly mistakes. Leaves us with 28 over 3, and that is our final answer, units squared.
Hey guys, I hope you're enjoying the video. If you're new here and you want more maths content, then please consider subscribing. If you're learning something, then hit that like button and comment down below to let me know what you want to learn next. I hope you enjoy the rest of the video.
Next question says the curve C has equation y equals x squared minus 4x plus 3, and it cuts the x-axis at A and B. Find the coordinates of A and B. All right, nice and simple. We're just going to make this equal 0. We get x minus 1, x minus 3. x is 1, x is 3. So A is 1, 0, B is 3, 0. All right, part B. Show that D, 4, 3 lies on C. All right, the best way to do this is you're going to take the x coordinate of 4 and sub it into our equation. 4 squared minus 4 times 4 plus 3 is 16 minus 16 plus 3, which is 3. Therefore, D, 4, 3 lies on C. Part C, find the integral x squared minus 4x plus 3 dx. Add 1 to the power will be x cubed, divide, be 1 over 3. Then we would get x squared. Minus 4 divided by 2 is minus 2. 3 integrates to 3x, and then don't forget your plus c. That's a classic, guys. Many of my memes on TikTok and Instagram, which you should all be following me, are all to do with forgetting the plus c. The finite region R, bounded by AD, AB, and the curve C, is shown in the diagram. Use your answer to part C to find the exact area of R. Now, many students get this question wrong. They don't know exactly how to find this kind of strange area R. I'll show you some ways that would be quite difficult to do. So a lot of them, they draw a line up from B. They want to find this triangle. And then they find the area in between these two curves and add them together. Now, it will work. Very long though. You'll be there for a long time. Remember, we're here for an efficient time, not a long time. We definitely need to use triangles. The rule is, where you see intersections, you should draw a line down. And there you can see a triangle. Now, if I fill in this blank space here, you can see one large right-angled triangle. This large right-angled triangle from A to D straight down. That's what we need to find the total area of. And then we need to subtract the yellow area by doing what we did in the previous example of just integrating between the x-coordinates of B and the x-coordinate of D, which is 4. And B we worked out to be 3. So this triangle here, we've actually worked out A was 1. So our big triangle, the base length is 3, the difference between 1 and 4. And the height is also 3. So we get 9 over 2. Now we're going to find this area here. For that, we're going to do the integral of our function between 3 and 4. Now we did that already. So we have 1/3 x cubed minus 2x squared plus 3x. Now we don't need the plus c anymore. Okay, let me show you guys how to sub in 4 and 3 in your calculator really quickly. So what you need to do, we're going to sub in 4 first. We're going to store as a. Then we're going to do 1/3 a to the power of 3 minus 2a squared plus 3a. So 4/3 minus. Now really quickly, all you need to do is press this calc button, change a to 3, and actually we just get 0 when we sub in 3. So the answer is just 4/3. Therefore, the region R, remember what we said, the region R is going to be the large triangle 9 over 2 minus 4/3. So 9 over 2 minus 4/3. It's 19 over 6 units squared. And that's it. So guys, this concludes integration. If you learned something, please hit the like button and subscribe. For more maths content, follow me on all my socials, all my memes on the plus C stuff. And as always, I look forward to seeing you in my next video. I'm going to be doing exponentials and logarithms. Peace out, guys.